come back to them if you need to. 2,100 kilogram car going at 25 meters per second. Driver sees a menacing deer ahead on the road, slams on the brakes, applying a force of negative 172,200 newtons. How long must the brakes be applied to come to a complete stop? Okay, what I want you guys to do first is write down the knowns and unknowns. So write down what we know about this problem. Write down what we don't know about this problem. Okay, so take a minute here. If you're having trouble, call me over and I will help. Okay, knowns and unknowns. All right, first thing we know is we know the mass, 2,100 kilograms. Thank you. 2,100 kilograms. We know that it is traveling 25 meters per second, so that's the initial velocity. It says it slams on the brakes, applying a force of negative 172,200. How long must the brakes be applied to come to a complete stop? So, how long, what's the time? And this is a time interval, so we've labeled it in the equation as delta t, but it is just time. It's just a specific time. We don't know how long that is. And it doesn't seem like it says anything about v final, so I'm just going to write v final, but I'm going to leave it blank. Why? Yep. So it is in the problem. It is in the problem. It says it comes to a complete stop, so it is in the problem. So we need to figure out what equation to use. So I look at my momentum equations, and I say to myself, okay, talks about mass, it talks about velocity. That looks like momentum. But it also talks about force. And there's only one equation that has force in it, and that's this first one. Okay, this first one here. So we're going to go ahead and we're going to set that equation up. So F times delta t equals delta p. Now, I'm kind of in a trouble on the delta p because it doesn't tell me anything about that. So I'm going back to my equations and I'm saying, oh yeah, delta p is p final minus p initial. Okay, so change in momentum. And I go back to my knowns and unknowns and I don't know any p's. Okay, well that's a problem. So I'm going back to my equation. And I'm saying to myself, well, what do I do with P? Oh. P equals mv. So what I need to do is I need to find the momentums. I need to find the final momentum. And I need to find the initial momentum. So what I want you to do now is solve the momentums and then try to solve the equation. Plug those momentums in and see if you can solve the equation. So go ahead and solve for PF and PI, and then try solving for T. Nope, no crash. So that's right. So PF would be mass times final velocity, which is 0 because it comes to a stop, so PF is 0. PI would be mass times initial velocity. That's going to be 52,500. So, change in momentum is final minus initial. So I take my final, which is 0, and I subtract my initial, which is 52,500. And that's all I got to do. You would divide this to the other side because it's multiplied, so the opposite of multiplying is dividing. So the time interval you get, 0.3. Which is a little ridiculous, but not as ridiculous as some of the other answers. So remember, it's got to be divided, not added. Okay,